Yo, 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 what's up, everybody? Welcome back. Today we are implementing GL clear, an OpenGL command, on our virtual graphics card. So, what does that mean? What is the context here? We are working on implementing a completely fake GPU with the intent of understanding what we would need to do if one day we want to make a real GPU. So the vision is one day we have like an FPGA, right? And like he's plugged into like some monitor and we can like connect this through some sort of like probably like maybe through some like companion computer, or maybe it's all put in the FPGA, but this connects to some sort of like Linux box, right? Or maybe not a Linux box, maybe just some sort of like microcontroller or something, right? With the intent of doing some sort of like 3D rendering, right? But what I don't really understand at this point in time is like what is like the responsibility of a GPU. I kind of understand what like the API of OpenGL suggests is the responsibility of GPU, but I don't really know. Like if I like type in a shader, if I like write a shader in OpenGL GLSL and I like upload that to the graphics card, what actually gets uploaded? I presume there's some sort of like Mesa compiler in the Linux world, or like OpenGL compiler that like has a backend for each type of GPU and like figures out exactly what type of format they support, and then they upload it and do some work, right? But what does that look like? I'm not really sure. And so I kind of figure before we get to like this point where we make a real graphics card with an FPGA, what we should do is we should understand what APIs are expected from a graphics card. And then even if we don't end up supporting Linux in the future, we'll at least have like a sane GPU design, maybe, right? So that's the kind of plan here. Where we're at right now is we have like this virtual machine Q email. We didn't write this, but we are integrating with him. He is an open source virtual machine used heavily on Linux. We have added to this a PCI card who has the ability to draw to QEmu's window. So we can draw a little smiley face in here or whatever, right? We have a kernel driver. Kernel. We have like, we'll kind of split here. We have like a driver here who knows how to look for this thing and to talk to him. And this kernel driver also exposes to user space a like DRM file handle. And we've like played this in a couple of ways. We've done some sort of like raw direct like frame buffer rendering through this interface that has like correctly shown up on the QEMU window, as well as we've implemented like a fixed function pipeline where we've added some commands like upload vertex buffer, upload texture, and upload like model transform, right? And we've like raw called these calls in our driver, and that has like resulted in something 3D rendered on the QEMU screen. What we're working on right now is instead of calling like GPU specific calls, we would like to be able to just use regular OpenGL in order to talk to this thing, right? As a stepping stone to get like eventually we'll get to like shaders and stuff, but like let's start with something simple. We'll start with GL clear. So we are integrating with this library called Mesa, who has like OpenGL implementations for a bunch of open source drivers, right? And so what he is going to do, what we are doing here is we're basically hooking up to the back end of him. He provides us all of these like nice APIs and calls out to us whenever he wants to do something. He like loads a driver. He like reads the name of our driver, which we've called like Sphero GPU, and he loads the appropriate driver and like calls callbacks for that driver. That makes sense. So we've kind of got to the point now where if we run this sequence of commands, we set a viewport of 1024 by 768, we set the clear color to green, we call GL clear, and we call GL flush. That doesn't fail. It doesn't do anything really right now. It doesn't do what we want it to do, but it doesn't crash, which means that we have all of our callbacks that we know what we have to implement now, if that makes sense. So we know that like they're going to create a context for OpenGL. And on that context, there's like a clear command. So, and right now in our clear command, we just kind of like write to some buffer that we allocated. So we know that we also know that the pipeline is going to do something along the lines of Mesa is going to call like a sequence of commands that's like, make me a render buffer. So he's like, allocate this thing, right? Which comes through, I think, create surface or something. He's going to then say like render to this thing. So then he's going to say like render there, please. Render to this. Then he's going to call clear. And between these sets of commands, we should be able to interact with our GPU to actually show something on QEMU. I think it's something like that. So what's kind of interesting right here is when they call like their like allocate command right now, we just call malloc on that thing to create like a pointer in our application just to like test that we understood the whole flow, right? So what we're doing right now, I think if we open our test app, right, is we allocate this buffer and then we print it out later, and it looks pretty green, 00ff00ff, pretty green, pretty green, I will say. And so the goal for today is to try to kind of move this from like some sort of like malloc buffer that we're using here onto like a GPU buffer that's actually written to on the GPU. So that means that we're gonna have to take this stuff, and instead of calling malloc when we allocate, could I please fucking expand this? Thank you. We are going to have to do something like in our kernel driver, we're going to have to expose some sort of like allocate resource, right? This is going to have to send over to our GPU that he wants to allocate a resource of this size, and the GPU is going to have to like hold that resource here, right? Then when we call clear, we're going to have to ask our kernel driver to clear this thing, which will send a command to the GPU who will actually do the clearing. And so that's kind of the plan for today, is just kind of see if we can get that working. I expect that there's other things that will come up, but I don't know what they are. And thinking ahead is for nerds, so we'll just kind of run it and see what happens. Yeah. So I guess probably where we want to start is on this like DRM resource create, I think. Maybe we have to start a little earlier. There's a concept of a screen that we've been working with, and as well as a context. It looks like the screen is kind of like your top level. All interactions with your GPU start here. In like Mesa world, in like the OpenGL implementation, right? He has stuff on him like resource create. Notice that the resource create is not part of like a context, which is like has all of the OpenGL commands. This is part of like kind of global resource management, which can be shared between multiple contexts. So I'm pretty sure, if I remember correctly, that this is where we start, and he will try to basically make something that gives us like a width and a height, and we just kind of say like, okay, we'll use 4 bytes for this thing. So I guess what we're gonna want to do here is we're gonna do something like, we're gonna have to somehow talk to our GPU driver, which means that we need to like have a file descriptor to talk to, which is exposed through this get screen fd command, I think. Who we implement by doing what? Returning -1. So that's not great. And maybe we internally don't have to use this. We don't, maybe don't. He creates us with a file descriptor, right? So he says, hey, we are DRM screen. Here is a file descriptor for you to use, which I assume is the file descriptor for our driver handle. So probably we just have to write that down somewhere. What we can do is we can make like a Sphero screen like this. And in him, he's going to have a pipe screen inside. And what we can do is we can just also store the file descriptor here. Right? And so what we'll do here is we'll actually allocate a Sphero screen here. And what we'll do is all of our like base class stuff we'll put here, like this. And then we will return like this. We will return the base class. And since this is the first argument of our structure, in all future calls where they pass us a pipe screen, we can just cast this back to our guy, right? So when we go into like DRM resource create now, hey, applying what we've learned. Yeah, what we've learned. Have you guys, when I was a kid, I watched a lot of VeggieTales, and they had this song where like, what we've learned today applies to our lives today. And that sure does, you know? Then they talk about some Bible stuff, but that part's not relevant here. So we should be able to go like, what am I trying to do? Here on resource creation, we're going to have to use that file descriptor, right? So I guess up here somewhere we'll define this thing, and then I forgot most importantly here, we made this struct so that we could assign fd is equal to fd, which means that when they ask us to create some sort of texture, we should be able to talk to the GPU by saying like, this will be called pipe screen here, and then we'll say like struct Sphero screen star is equal to struct sphero screen star ps. Which should allow us to go like, hold on. We can do this here. Like, presumably we can do some sort of like DRM call, right, on our screen file descriptor. Presumably. And we're going to have some sort of ioctl that's like related to our driver. It's like going to be specific to our driver. So let's see if we have like sphero drm.h. Here we have like create GPU object is probably going to be what we want to call. And we might want to create a GPU object with a specific size. I don't know if that's part of this right now. It is. So we should probably just be able to call create GPU object, and that should be fine. Recommended a C stream. Finally, Twitch knows what's good. Joe, what's up? Yo. Happy to have you. Although I wouldn't really consider us a C stream, but you know, I'll take it for now. We are running C at this moment in time. Okay, so what else goes into this DRM ioctl call? He says it's undeclared, which is annoying. So I think that we probably have to like, is anyone else in this whole project called DRM ioctl? They do, so we can just kind of see who they include. They come from xf86drm.h. Okay. Okay, let's just do that. So now we have DRM ioctl. Now we don't have like our ioctls, which is going to be annoying. So we need to like include like sphero drm.h or something. But I doubt that the project knows where our kernel headers are right now. So this also probably comes from like drm/drm public.h or maybe even uAPI. I'm not sure, but we'll have to figure this out. And then most importantly, what does DRM ioctl need? He needs the request and the arguments. Right, so here we're gonna have to make a struct DRM sphero create GPU opt. Create rec or something. And then we'll do something like size is equal to the width times the height, probably times 4. I guess, yeah, I don't know. Do we want to allocate this thing with like a fixed size? Maybe not, right? Maybe we want to allow it, maybe we want like a special create texture request and just give it the width and the height individually, and it can choose on the GPU how it wants to represent that, right? Because I don't think that we really are going to like map this data necessarily. So I kind of feel like this is like a new command. So maybe we'll call this like create, define drm sphero create GL text or something. I'm going to prefix this with GL to kind of like disambiguate from the old commands. These will eventually get deleted, but for now I just don't want to get confused. So we'll kind of do it this way. And we'll say that we have some sort of like create texture params. Create GL text. And he is going to then just say that he has like, you know, width and height or something, right? That seems reasonable to me. Is there anything else that we need on this thing? I guess we will come back if we ever decide that there's more. I think that makes sense. So we'll say this is create GL text like this. And we'll go width is equal to width 0 and height is height 0. What is sphero? That's my name. The sphero is not bound by categorization, although Zig. Oh, yeah, because somebody was asking what language I guess then, or I use, I guess. I was missing some notes. some Twitch chat messages. And then you guys are talking about C++, and I'm just gonna ignore that for a second because I don't want to think about it. Okay, so this is gonna call whatever our thing we just called it was DRM sphere create GL text. So this is gonna call it. Oh, copy doesn't work that way between projects. Fine. And we are going to pass in the create rec. Okay, if this is not equal to 0, we have a fucking problem. So here we will, I don't know, printf, I don't know. Can this fail? Return null? I guess. I don't know if that's like legal or like a legal way to fail this, but fix me, check if this is legal. I don't know. The real teal seal, thank you for the prime, much appreciated. And then this stuff probably still has to get done. And here we probably also have to like free resource. And then our ret data, this is going to turn into like a GPU object handle, which is a U32. Right, so we're going to like call this thing, and then our handle is just going to be create rec handle. Cool. Seems reasonable. This certainly will not build for all sorts of reasons, but I would like to, at the very least, figure out how to get my include directory set up right. Right, so yeah, he's like, what the fuck is this like Sphero DRM shit? So I assume that this is like a configure step thing. Can I like in build Mesa, can I like add an include directory? Let's see here. Mason add include there. I guess we could just like add it into the build system for now. Just so I don't have to think about it. Include, is there like a include directories anywhere? There is. So we probably want like Sphero Mason build. Here we want to just add one here probably, and we can just say like streamer work GPU testing env. Like I just don't want to think about it. Linux. Source Linux include UAPI. And then is it typical when you use like these UAPI includes? Whatever. That's fine. That's fine. We'll just run it this way. Okay, so does this work now? Oh, wait, was I on the wrong folder? Oh, it's fine, it's fine. So he reconfigures. He's mad because double quotes are not supported. Use single quotes, that's crazy. But, you know, we'll do what you ask. And it looks like he's fine. We'll eventually get to compile some more compilation failures on our individual file, but we'll give it a sec. Does Mason support relative paths there for people cloning later? Maybe. I was going to like add it as like a configuration step later. I just didn't want to fucking figure it out right now. So I can put fix me in there. He's mad because attempting to use kernel headers from user space. So where the fuck is this supposed to go? Oh, maybe. Hold on. DRM, like there's like going to be some sort of like vert GPU DRM that we were referencing. So like who figures this shit out, right? So let's maybe in here, surely in our project, vert GPU DRM is used somewhere, right? So they come from DRM UAPI, which looks very similar. I actually don't see the problem here. It is just a warning, but then we're trying to get into Linux compiler types. Can we look at like what they do for vert? It looks like they have their own includes here. So maybe we copy our thing. We can maybe copy into here. Linux include UAPI DRM Sphero DRM.h. We could maybe try that. And then not do this. And then in Sphero DRM Winsys, we can say UAPI like this. And see if that fixes it. There's a perfect way to deal with collisions in all language. Prefix with a stupid word. That's what separates us from the animals. Okay, so now he's mad that it looks like the included stuff has been resolved, and now he's mad about other stuff, which is fair. So 129, he's mad that data no longer exists. So we'll kind of just comment out anybody who's using data before, because these will need to get implemented more correctly later. But for now, create rec handle. This should be a dot, not an arrow. All right. So it looks like we compiled, which is pretty sick. Now, what is going to happen here is this is going to fail. This is going to fail because we haven't actually implemented that ioctl yet. We've created like the API for it. But if we are to actually run this thing, he's going to go like, yo, what the fuck? No? This should fail. It should. I don't know why it's not. Oh, he is saying hello there. We're just not noticing the error probably, which is kind of annoying, but it's fine. We do, it's fine. We'll deal with this later. It looks like it's legal, but maybe we should say, maybe our test app isn't like correctly error checking or something. It's very possible. Very possible. So for now, we'll just use this printf. Create text failed. We'll just use this. And then we will go into our implementation and try to implement this thing. So we need to do one of these, I guess. So this defines Sphero create GL text, and this defines what parameters it's supposed to take, which is DRM Sphero create GL text. DRM Sphero create GL text. And then we go into our driver implementation, and we add that as a thing that we try to do. So this is create GL text, and here we actually have to do something. Sphero GPU create GL text octal. And I guess it'll look similar to GPU create GPU octal. I don't know. Maybe. We can start here and just kind of see. Create GL text octal. Right. Okay, so this thing comes in and we get a set of create GL text params, right? I think that's what we called it. And before we were creating a gem object backed by shared memory, which seems unlikely to be what I want here. Right, we're gonna have to like create like a resource handle that gets uploaded to the GPU. So for now, can we just not do the gem side of things? Like theoretically we don't need any like user space interaction with this buffer. right? Theoretically, this is, I mean, in the future, if we implement like read texture, then we will. But at this point, we don't. So we can kind of just like not. I guess the handle we do have like gem handles that we're leveraging here. So what does this like gem shmem create do? We don't have like our environment here. So let's just try to set that up real quick. We haven't ever done any like GPU backed buffers, which is a little confusing. But theoretically, we should allocate one of these like gem objects, which is like this like generic interface. And we should then assign like a hardware ID to that thing. Probably. And we probably need to implement some form of callbacks on that thing. Probably as well. So let's see. Create GL text. So this gem shmem calls gem shmem create, which calls gem shmem create. And he creates a gem object with gem create object. It looks like, or if that doesn't exist, he does something else. Do we implement this? We do not. We don't implement that. So he's just doing like a fucking malloc, essentially. It looks like. Then he does DRM gem object init. So this is probably a key piece that we have to do. And then we don't have to create mmap offsets probably because we're not mmapping that thing. So I think it's mostly just this. And then yeah, it looks like that's fine. I don't know what like gem create object is supposed to do here. What do they do in like the vert IO path? They just do this. That has functions associated with it. But we're not using any of these probably. We're just using this for like the handle tracking. They have like scatter gather table stuff as well. Did the gem shmem stuff assign funcs? He did here. So probably there's a chance that we're gonna want to implement some of these. I'm not really sure. I don't really know what they do yet. Like presumably this get scatter gather table is gonna be. I guess that's only if we're trying to like actually upload stuff. I think it's probably fine. I think it's probably fine to just skip out all of this and just not have a concrete implementation. I think it's fine. Okay. So let's see what happens if we just do this. I'm not really sure what'll happen, but it seems like it might work. So here we have our device. Our object needs to be allocated. Right, so where were we a second ago? Where that was what they did? It was basically this. Okay, so we're gonna say like struct DRM gem object obj is equal to size of obj. Okay. Then the size here is the object size. So what happens with size? What did they pass in our reference case? Size was the size of the object we're creating. Right, so that's going to be passed in as the parameter here, which I guess, why do they need that for the generic object? What do they do with that? Why is this shmem related? Whoa. Okay. Why is this happening? So they say like, hey, there's like a shared memory file related to this thing, and then size is used as like hmm. Very interesting. This is used actually all over the place. TTM stuff, QXL object. Okay. I didn't think we need, like, I didn't really think we'd had a size, to be honest. Maybe we have to understand this a little better. We might need to understand this a little better. So, maybe we ask the idiot. Maybe we ask the idiot a little bit. He might have some advice for us. Can I allocate a gem object that is fully backed by the GPU? Question mark. Sure. Let's see what. This is useless. Fuck off. Shut the fuck up. Shut the fuck up. Shut the fuck up. No, I mean, how would a kernel driver implement gem object allocation without knowing? That's so stupid. It's not. He's not gonna help. He's so stupid. I wanted to look at like DRM driver guide, probably, and we want to look at like memory management here. And we want to just skim this again. So gem splits creation of GM objects and allocation of the memory that backs them into two distinct operations. Gem objects are represented by a struct of this, right? Drivers usually need to extend gem objects with private information and thus create a driver-specific gem object structure. Right, that makes sense. That's kind of how I feel right now. If you call him an idiot, he won't be helpful. To create a gem object, a driver allocates memory for an instance of this specific gem object type and initializes the embedded struct with a call to this. The function takes a pointer to the DRM device, a pointer to the gem object, and the buffer object size in bytes. Gem uses shmem to allocate anonymous page table memory. This will create an shmfs file of the requested size and store it into the struct this. This memory is used either as main storage for the object when the graphics card uses system memory directly, or as a backing store otherwise. Drivers are responsible for actual physical page allocation by this. Okay. Note that they can decide to allocate pages when initializing gem object or delay allocation until the memory is needed. For instance, when a page fault occurs as a result of user space memory access, or when the driver needs to start a DMA transfer involving the memory. Okay, I can see what this is for then. This is like, if we are going to transfer texture data, we would like create a gem object, get the object handle, and use that to like map. So maybe gem objects are like overkill for what we want right now. It feels like overkill. Hey, been a while since I dropped by. Looks like you've made some pretty cool progress. Hey, yeah, happy to have you. What's up? It does feel like we've got some pretty good progress going, yeah. So I think I just won't create a gem object. That's kind of how I'm feeling right now. And so the handle that we return to the caller will just be something else. We'll just kind of like hand roll it. I think that's probably fine. Especially, I'm sure that we will probably we will want the gem stuff later if we are actually uploading textures. But right now, we're only creating this texture as like a render buffer target, so we don't have to worry about it. Oh, they talked about private. Oh, did they? Ooh, anonymous page table is not always desired. For instance, when the hardware requires physically contiguous system memory, as is often the case, drivers can create gem with no SHMFS backing by initializing this with this, which still wants a size. So this looks like he's saying this is for like using like CMA allocators, contiguous system memory. So this also doesn't really feel like what I want. I think for now, I'm just going to skip all of this, stop trying to overcomplicate things, and we will just send to our graphics card a call to create this thing with a width and height, which means that we have to like design an API for this. So we're going to have like sphero reg command create GL text for now. And all we're going to do is we're just going to fucking write to some registers to trigger that thing to happen. So, like, we have an example like here. Okay. So we're kind of like in this function, and let's just be like, yo, make me a thing, please. So we have like width and height as U32s. So we'll just be like, yo, params width, go here. Params height, go here. And then the command is going to be like create GL text. Now, we're going to need some way to refer to this thing later. I am almost certain, which means that we should also probably like keep track of how many buffers we've allocated so that we can give them an ID. So maybe we'll say like ID width height. Yeah, let's do that. So we will create a new ID here, and for now we'll just do the stupid thing and say that the we have like a UN64T hardware ID here. And I guess that means that the hardware ID will take up 2 registers. And we'll just go like priv hardware ID plus equals 1. And we will say, yo, I want this to be priv hardware ID shift left by 32 and priv hardware ID. Wrong way around, this way. Lowest, highest is typically how we're doing this. And certainly this needs to be like surely needs to be mutex protected or something, whatever. Surely. Okay. So then this should trigger the texture creation, and we will put the hardware ID back in the output here. So drm sphero drm.h. Here we're saying that our handle is E64. It's kind of what we're saying here. And we'll just say that the params handle is equal to priv hardware ID. Okay. Sure. Then we return 0. Full success. Simple. Now we need to implement the GPU side of this. So the GPU has to like receive this command and actually do the allocation, right? So we go over here and we say next shell qemu shell, get into our qemu development environment, which is very subtly different than our other development environments for reasons I don't really remember, but whatever. And in here we go to like source qemu. Okay. So we need to make sure that we set the command name the same here between our 2 guys. So this was create GL text here. So let's just copy that and go to sphero.c and we paste this here. For those of you who've been following along in VODs, but not live, we did kind of refactor in happy hour today the way that we send commands to the GPU. It's basically the same, except we just have like one command and argument register instead of having like specific registers for each sets of things that we want to do, because we figured that would be more extendable. So now we have this like sphero run command here, and he's just going to say that he has sphero reg command create GL text, and he's going to probably assert some sort of like, mutex protect some sort of graphics memory, probably, and he's going to pull the address of this thing out of the arguments, except we need to make sure that we get what did we actually say that we were doing? We're not pushing anything. We are getting the hardware ID as U64. Hardware ID, so it's hardware ID U64, width U32, height U32. Yeah, okay. So this is going to be hardware ID like this. Then we have the width is args plus 2, and the height is args plus 3. Okay. Cool. And then we just need to do something with this. So we need to like create a texture and stick it somewhere. So we probably want like a hash map of hardware IDs somewhere. Do they have like hash table, G hash table? Is this what people use everywhere? Like monitor.c uses like G hash table star, sure, which comes from glib. Is there like Q hash? Yeah, okay, we'll just use this thing. That seems reasonable. Seems reasonable. So here we're gonna create a map of hardware IDs to buffers, I guess. And I don't really know where this is gonna live right now, but we can probably just stick it in like the top level Sphero state. So we'll call this hardware buffers. Maybe we'll even call this textures for now, because who knows if we're gonna have like other stuff, right? Can we look for like how you're supposed to use this thing? You create a new hash table with some sort of equality comparison function. And this takes in a pointer A and B. So the keys here, how do you like use keys? Your keys are just void stars. I see. So you're using, keys are void stars, and then you have to define hash functions that are for the like type that you've given it, right? So if you're giving in strings, then you're going to do something. Cast are wrong. I don't think they are. There they are. You're right. In fact, these just shouldn't be cast at all. Okay, so can we look for like whoever calls like G hash table in it? I think he was. They produced wrong results. I think he was right. Okay, so who calls this? Like, tons of people. So like this guy has a translators who has G direct hash and G direct equal. Interesting. So what do these do? G int 64, G int, G stir. Okay. Sure. So we probably yoink these. We probably yoink these. We probably don't want string hashing. We are kind of shoving our keys, our hardware IDs. Yeah, so I think we just use either direct. Yeah, I'm assuming that we want direct, right? So we're kind of like embedding the int64 as a void star. Like we're casting the int64 and acting like it's an address. And then the direct hash probably like works correctly. Let's see if G hash table insert. Yeah, so he casts T here. Oh, which is a pointer. All right, let's see if there's like any other uses of this guy. Null, null. Whoa, what happens if we call null on this thing? Okay. Does it say what happens if they're null? Hash values returned by hash func are used to determine where keys are stored within the ghash table. The direct hash, all of these guys are provided for some common types of keys. If hash func is null, then gdirect hash is used. All right. So can we look up, like, does it tell us what like gdirect hash does? Converts a pointer to a hash value. It can be passed to ghash table new as the hash function when using opaque pointers compared by pointer value as keys. This is hash is also appropriate for keys that are integers stored in pointers. Yeah, okay. All right, so that's kind of exact. That feels like what I want, right? Just kind of hand wavy. Feels like what I want. So let's just fucking run it. So we have, I think that we embedded our hash table in like our top level structure as textures here. So here we want to do something that's like on init. We want to do like s textures. You'll g hash table init. Right, was what it's called, I think. G hash table new, sorry. which seems fine. And then we need to upload our texture to this thing. So when we say create a GL text, this thing, now we actually have to do some interesting work. So we're going to like I don't know, as textures g hash table insert to this thing with the key of g int to pointer hardware ID, right? And the value is going to be like the thing we malloc. So we're going to like malloc width times height times 4 or something, right? And we're going to say like void star data. And we're going to insert the data here. Presumably we need some sort of like lock for this thing. So I don't know. I don't really feel like this is the same concept as all of this stuff that we were doing before, so we're gonna call it something else, but we'll call it like GL, no, texture protected, I don't know, man. I don't know, we'll fucking figure it out. So we're gonna say that our texture protected dot lock needs to be initialized. Okay, and our texture protected textures is gonna be that. Sure, fuck it. Fuck it. Which means that we're gonna have to like lock a thing. But this is texture protected on both of these and texture protected texture. Okay. Sure. Seems reasonable to me. Seems reasonable to me. So if we've done everything right, we should end up with a piece of data that is like available to us, that has been allocated with the correct size, right? So we should be able to do something like, let's at the very least printf here, allocating GL texture of size, right? Let's just see what happens here. And then it's like uint 64 t size equal to width times height times 4. Sure. Sure. So let's go to build QEMU, build our new QEMU. Give him a sec. Chillin'. Okay, now we go into our Linux kernel and we build that. Sorry. Give him a sec to think. So much allocation without freeing will probably lead to memory blow up. Yep, I know. We tackle that later, but you're right that we should at least like note like fix me, this must get removed somewhere, right? But for now, we don't worry about it. It's a problem for future me. Future me. And then I guess we also want to build Mesa. So build.sh. And I guess we probably restart the VM to get the new kernel and QEMU. So just give him a sec. He's still building. I don't know why he's building so much stuff there, but whatever. We wait for him to boot and then turn on networking. Like that. And then we should be able to call build.sh and run all of our stuff. And what we're hoping to see here is that in this window down here on the bottom right, we're hoping to see allocating GL texture. And if we don't see that, then we did not do this right. Create text failed. Okay, so that means that the DRM call that's being issued here did not work correctly, which is surprising, right? That's pretty surprising because we would think that we added this thing and it's like, you know, he's defined fine. Oh, is it, am I supposed to call DRM ioctal? That's very possible that I just called the wrong thing here. Can we look for other uses of this thing? Yeah, they're all prefixed with ioctal, so it's probably I just fucked up. Fucked up a little bit. It's okay. We try again. He's uploading a bunch of like the libraries that he compiled. Okay, yeah, allocating texture of size this. So it looks like we have piped all the way through to the graphics card through the kernel driver correctly, which is a big win. That's actually a major win for us. That's actually super fucking sick. I expected that to be more painful. So it looks like the refactor we did today really fucking helped. Okay, so now when what happens? Somebody is going to try to bind this frame buffer as like the draw buffer. So I think that that's under context callbacks. They call set frame buffer state. And we just assign the texture directly, which is fine. Does our Sphero resource, he has a handle at him. So that actually makes it all the way probably to the GL clear call. Probably. So here we should be able to just execute clear. Now, I was also kind of interested to see what other drivers do here. So somebody like virgl clear, what does he do? He calls encode clear. So he's doing exactly what we're doing, is he's sending a command to the GPU to actually execute the clear. So that's pretty fucking cool. That's pretty fucking cool. So now we should be able to go like, hey, I want my Sphero screen here. And this comes from probably like CTX PC screen. Yeah, here we go. And this is a pipe screen, so we should be legally allowed to construct Sphero screen here. Cast, like this. And we should be able to go like, just basically do exactly what we did down here, where we created an ioctal to do an upload here. Now we want to do an ioctal to use that thing. Right, so here we have like, we're not going to do a create here. We're going to do like clear, I guess. And he's going to have to do something, right? So presumably he's going to want to write to like the handle of this thing. I guess we'll call this GL clear for now. Again, I'm going to change all of these GLs probably later, but for now I'm just going to leave them so that we can disambiguate between our old shitty code and the GL code. And I guess he's going to have something that's like handle is going to be like create rec. Nope. This is going to come from the texture that we're updating, which we have on the pipe context. We have CTX bound texture, right? Right, so we should just be able to do this. And then what? We probably want to pass on some of the parameters that we're getting here, right? So we're going to want like color is going to be like this, probably. Get like the unsigned integers out of this color buffer that's being passed to us. Right, so I think that what's happening here is these colors are actually floats, but you can pass them as unsigned integers if you want, which is just like a bit cast of the float to 32-bit unit, U32, which is nice for us here because then we can, in the kernel, which doesn't have floating point support, represent these things as U32s just for data transfer. Yeah, and we'll put like fix me, like use depth, stencil, buffers, etc. But I do want to pass on the scissor state like now. So the scissor state is kind of like where on the screen you're doing the clear on. So we'll call this scissor, I guess. which means that maybe here we'll just kind of call this like this. Like this. So here we say min max, and here we say y, 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 y. Okay. Which means that this has to get passed on here. And we'll say clear failed. All right. Cool. Seems reasonable. And then we just return like this. And I guess that's kind of it. Like, there's nothing more to do here. This just goes away. Seems reasonable. Seems reasonable. Okay. So that means something. Something. I guess we go back into the kernel driver and we add this command. We need yet another command. So we'll start on the user space interface side. So here we'll just say create GL text goes to GL clear. And we kind of have like GL clear ioctal, which means that we need a GL clear ioctal, right? And this is going to take some sort of like GL clear parameters, which don't exist yet. So we'll have to make those over here. So GL clear is going to work on some hardware handle. And then he's going to take in like min x, max x, and min y, max y, right? As well as the color. So we want color to be a 4 U32s. And then we'll put a note here. Floating points encoded bitcast to U32s. Just to be clear. Okay. Don't say scissoring D's. Come on. Try harder. Just try harder. You know, you can be funny without just repeating the same 3 jokes forever and ever. Okay, so this is what was it? GL clear? Was that what we called it? I think we did. I think we did. And then up here we need to define GL clear as the next number up. Sure, maybe. I don't know. Okay, so now we actually have to like pass the correct parameters on. So our GL clear, where we have our parameters, I guess, are going to be like all of these things. So I'm just gonna put these here so we don't forget. So we have params handle the lower bits of it, the higher bits of it. We're gonna have params color 0. And I guess we're gonna go like this. 4, 5, 6. 1, 2, 3. Every time I come to your stream or YouTube, you're always coding something complex. How do you find the motivation to keep going on a project? Like, how can you map what you need to do now to where you need to be in your project? I always find myself struggling with that when I start a project. Yeah, I mean, I think I have like, I came up with I find for myself that if a project drags too long, I start to lose interest. I find that for myself, I'm pretty interested for the first little bit, kind of just because, or else I wouldn't be doing it. And then I find that for me, splitting things into smaller projects, or at least things that I can think of for smaller projects, really helps. I find that streaming is like a pretty good motivator to like make consistent progress. At the very least, I think so. I'm not really sure. Not really sure there. It feels like it's working. Yeah, so if I sit down every day, I'm like, I need to do something. It's like, what's the next thing? It's kind of about the extent of how much I have to think about it. I'm lucky that I am very somewhat internally motivated. So I don't know. It's kind of going to be different for everyone, right? So like, I can't really say what will work for you. I just know I've like learned to trick my own brain so that it works like to do what works for me. You know? You know? Also, there's something like I just find it like hella satisfying, dude. It's super fun. It's super fun. Okay, so here we're gonna execute a command that's like, what is this? GL clear. And for me, complexity doesn't really cause any like loss in interest. Complexity is probably what causes the interest to begin with. You know, it's like if doing things I haven't done before is the fun part. How many regs do you have? As many as we want, to be honest. We probably don't have 10 right now. I think that we had 4. We fixed it to 4 earlier today, but we can just make it 10, you know? We can do whatever we want. As long as our IO space is big enough, then we're chilling. GL clear ioctl. What did I fucking call this thing? Great, GL clear. Fuck that shit. It's GL clear. So this we have 128 over 4. 32, so 10 is plenty. We have plenty of room for 10. Okay. So that might work. Does our like kernel driver compile? If our kernel driver compiles, we can move on to the QEMU side. Yes, that's chilling. That's pretty chilling. And so let's just get this GL clear command over to the QEMU side, which is here. We paste that shit. And now we have to implement this thing. So our GL clear is going to have to look up the hardware ID. So I guess we want to kind of go back into this thing and just kind of copy this for a second so that we know what our parameters are. Right, so we'll just kind of slap this like this. We definitely don't want to forget to type break because that always fucks us. And so I guess we will say how do we do this before? Oh, we just do a unit64 cast. God, we're smart sometimes. That's tricky. We're tricky. So we can say a unit64t handle is a unit64t star s args. I guess we should do this assertion that we're a little endian. Oh, we do that there. Sick. We have... Oh, we need regs here to be num arg regs. This needs to be up to 10. Okay, so it's handle color. So we have unit32 t star unit float star color is going to be, or R is 3, so s args plus 2. There we go. And this is going to be I think that it seems to be okay with this. So we'll kind of do this for now. Then we need to do min x. So we have, this is u32 min x, which is unit 32c star, like this, args plus 6, 7, oops, 7, hello, 7, 8, 9, then this is max x, min y, max y. All right. These are all off by 1 because our arguments are offset by 1. The command register is the first one, and then all the other ones are the same. Shouldn't the index be the same? No, yeah, it's because they're off by 1. So when we push into the args thing, we push it as reg -1 because reg 0 is the command. So really, we probably only need 9 arguments, to be honest. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, this is 10. All right, sure, fuck it. Okay, so now we have all the stuff we care about, so we can actually do something. So we can like kind of go, I guess our texture, we kind of need his stride encoded, huh? We kind of need the stride. So instead of just storing the data into the textures, I guess we will store a like sphero texture. And this is just gonna have a stride as well as data. And maybe this is like unit 32 T star data. Then we'll call this width. Stride pix. Yeah, we'll call that. All right. Sure. I hate storing this as maybe no, we'll store it as unit 8s. That's easier. We'll call it stride in bytes. Sure. So then when we insert into our texture list, wherever the fuck we do that, create GL text. Here, we are going to say that the stride is width times 4. And this is actually going to be mallocing a size of sphero texture. I guess this is kind of going to be more like sphero texture star texture is malloc size of texture. Then we have texture data, which sucks. You could like fix me single allocation, right? That's definitely possible. Remember when you were running a kernel module and we had that whole stack alignment issue? You may be interested to know that I just PR'd the Zig proposal, which allows Zig to represent that. Oh, hell yeah, dude. Didn't this get PR? Didn't you PR? Oh, you PR'd the proposal. So this is the actual implementation. Because I was going to say, didn't you set the proposal like a month ago? Oh, hell yeah, dude. Let's go. That's pretty exciting. That's pretty exciting. Which means that the only real blocker that we hit so far for that would be the like opaque pointer stuff, which I'm sure is still a big problem, but that's pretty sick. Pretty sick. Happy to hear it. Okay. So this insertion, we have texture, size of this thing, texture data, texture stride, like this. And then these guys want some float casts here. So we'll do a float star like this. And this guy doesn't get data, he gets texture inserted here. So now we can look up the texture by the handle, right? So we'll lock our little mutex and do our little stuff. So we have like G hash table lookup, probably would be my guess here. So we want gint to pointer on the handle, probably. And then we have like sphero texture star texture is redefined. Oh god, okay, fine. We'll use curly braces. We'll fucking stick our curly braces in. If you're gonna be like that. Okay. So then what? What? We have like for y is equal to min y. Yeah, for y is equal to min y is less than max y plus y. And we do the same for x. Sorry, x. We can do unit 32t here, I guess. Why not? Why is he mad? Oh, because these need to be dereferenced. Oh, my life is so hard. So many stars everywhere. So for each of these, we just set the pixel, right? So we set like for 0 to 4. Nope, wrong language. Int c equals 0. C is less than 4 plus c. And I guess we kind of just we can even store this as like float star C is equal to color buff is this. And we don't have to get RGB&A. We just go with RGB&A like piece by piece. So we go like color buff C like this and use that as a result into something. So it's like texture dot data. We index this into like y times texture stride plus x times 4 plus c. I believe. Right? Because this gives us like line by line, this gives us pixel by pixel, and then this gives us pixel component. So I think that this just gets like this. I think. Maybe. I mean, who fucking knows? I don't, but feels like it might work. And then can we then need to like display this texture somehow? Yeah, I guess we want to display this texture. So for now, can we do what we did on the frame buffer stuff? So here we can commit frame. Let's just do this. I'm not going to really think about deduplication for now. So here we should be able to set a thing that comes from. So this doesn't take the output width anymore. This takes the texture stride over. I guess we need to this if we're going to do this, our texture should hold the width and height as well. Okay. Right, and then that means that we can initialize this thing with texture width and texture height. We can use ARGB. That's probably not quite right, but we'll come back to that. Sphero output width times 4. This is the stride, so this is texture stride and texture data. This is making an assumption that the texture that we're clearing, when we clear, we immediately want to display. I don't think that's true, but it's good enough for now. It's good enough for now. Let's see what that does. You know, I'm not like 100% against this. Not 100% against it. So we've built the virtual machine. Let's build the kernel. I think that it was already built, but let's just make sure. Okay, let's kill our virtual machine and run it again. And let's then root test app dev dri card1. And let's then build over here. He's mad because initialization of unsigned int from const unsigned int makes, oh, because you have to memcopy in there. I'm a fucking dumbass. So this needs to be a memcopy. So I will say clear rec color, memcopy this from color unsigned integer. What are the arguments here? It's destination, source, and number. So this is 4 times size of e32. Clear rec. There we go. All right. Moment of truth. Moment of truth. So we're kind of hoping to just see this turn a color in a second. Oh, wait. UDHCPC. We have to enable networking for that to work. Let's run it again. Okay, give him a sec, Segmentation fall, let's go, baby. Let's see it. Oh, he actually tells us exactly where. Why is it doing that? That's kind of cool. This is in DRM WinSys 129. 129 here? Oh, because scissor state's not set. Ah. Okay. So here we're actually going to go like if scissor state. I kind of assumed that the GL viewport would set the scissor state. I'm not going to lie. That's kind of surprising to me. But we'll come back to this. We'll say all of these get clear rec like this, except these all have to be dots, and these all have to be semicolons. That's actually quite surprising to me, to be honest. Because that means that GL viewport is not doing what I thought it was doing. Okay, so he immediately says, "Hi, Mom, we're finished." This did something. We see, like, an effect here for sure, but it's not what we were hoping for. Yeah, that's not great. Oopsies, what the fuck did I just do? Can we try, I mean, if we got the RGBA kind of messed up, then it could be from that. So can we go to our test app, which we are working on maybe here? And can we like just try to make it white just to avoid, you know, mistakes related to that? Fuck. Nick shell. Aren't min-max values random now? That's a good point. I meant to zero. No, they should be zero. They should be zero, I'm pretty sure. Because I think that if you initialize one field of a structure, all of the other ones get zero initialized. But I did mean to go into the QEMU stuff and fix that. I wanted to do if min x min y or max x is equal to 0. I want to do like max x is equal to like our texture width, and same for max y. I did want to do that. I could be wrong with that one field thing as well, but fuck it. We'll run it and see what happens. So see test app. We need to turn on networking again. We need to do like, what am I trying to do? DHCPC, turn on networking so that we can run zig build. Copy that shit over. Need to deref inside the if. That's a good point. Dude, it's so annoying. Fuck this weakly typed fucking language, dude. That's so annoying. And then while we're here, let's also print the color. Printf got color buff of RGBA, right? Like, let's just, we might as well. Color buff 0, color buff 1, color buff 2, color buff 3. All right. We might as well. Might as well. All right. Go back up, run.sh. Go over here, we wait a second, and let's see what we got. Root, test app, dev, DRI, card 1. So we did get a 1111 color buff, which is pretty sick. We are still seeing this be completely black, which isn't really great. Right, that's not great. Let's kind of see what our like bounds are. So can we say like printf bounds are going to be %d or u, %u. I guess we'll say %u to %u like this, which is going to be like min x, min y. to max x, max y. We are still running, so let's just kind of... We all do also have to build our thing, huh? There's a lot of things that we have to remember. So much to build, so much to run. All right. Oops, wrong window. Serial. Here we go. All right. So we do get the correct bounds, which is good. This is still black, though, which is not good. That is not good. I guess it's possible that we are accidentally overwriting ourselves with that graphics hardware update thing. We saw this in pre-stream where this was causing problems because we had like we've done like multiple experiments here, so we were just trying to disable one, and then we had to pragma diagnostic GCC ignore w unused function or something. Diagnostics GCC diagnostic. There we go. I can remember. I know like the right words. I just don't know what order or if they're plural or past tense or present tense. So I just have to try them all every time. It's a hard life. All right. Root test dev dri card1. Yeah, still no go, huh? Still no go. Which is confusing because, like, I guess it means that we could have fucked this up. For sure, that's an option. I'm pretty sure that we saw this was effective before. So I'm like a little, we could see like an argument that this is a problem, but I feel like it's fine. Width, height. I mean, this RGBA shouldn't matter, right? Because we have everything coming in as one. Can we like printf texture data maybe? Right, what are we seeing here? Data was allocated with the right size, right? This is size, which is width times height times 4, which seems pretty good. Pretty good. Stride is width times 4. Yeah, so we're going y times stride plus x plus 4 times 4 plus c. Let's just double check bounds here. Zero, 0 to 1024 by 768. Yes, that seems right. Because it starts 0, 0 here. So we could maybe take... Oh, wait a second. I'm a dumbass. These are floats. So we have to multiply by 255. We do have to multiply by 255 to get them to uint 8 t's, you know? It's a hard life here. Run. Run, 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 run. Root. Test app dev dri card1. Let's fucking go, dude. That's actually so sick. That's actually so fucking sick. I know that like all we're seeing is a white screen, but we've actually we've actually implemented a full OpenGL call. That's so cool, right? Like just to be clear about what is happening here, we have a Mesa driver that has like Sphero GPU. He's implemented all sorts of stuff on here, but one of the things he's implemented is clear. We implemented a make texture or like resource create and frame buffer bind FB. So what happens is we create a resource. This goes over to our like kernel driver, which sends over to the sorry, I'm trying to get this like a little bit bigger. There we go. He sends a create resource over to the PCI bus, to the GPU. which then with like an ID, we like return that ID back, and when we bind the frame buffer, this is just like all like software stuff in Mesa that says like, okay, we remember this is what we're drawing. And then when we clear, this takes that ID and he goes over to the kernel driver and he says like, ID, color, as well as like area. So what happens here is in the PCI card, when he gets this like allocation, he like creates a buffer of that size, and then when he calls the clear, he like writes into the appropriate section of that size, which is so fucking sick. It just means that we have like the whole pipeline for like how to send stuff to the GPU and make it do stuff. That's like all there. Which means like the rest is not like trivial, but it means that we have proof of concept that like we can do anything, which is like so massive. That's so sick. Right? Because now all our application is doing, our application's so basic, right? We're not even doing anything specific to our GPU in this test app. We're just calling GL clear. That's so sick. So sick. Yeah. Okay, I'm really happy with that. I think usually I wouldn't necessarily want to call it here, but I think that I need some time to think about what the next thing to do is. We're at like 1.5 hours for stream, which I think is pretty good. We've been kind of trending on the long side recently, and I think a 1.5 hour video is actually way more digestible for people than like a 3-hour one. So, you know, it's not the end of the world. So we're gonna call it there. I'm actually like really pleased with that. There's some cleanup to do here for sure. There's some unanswered questions here about like the scissoring and stuff like that, but overall, pretty exciting. So, thank you for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 3:30 Pacific time now, so anywhere between 3 hours ago and half an hour from now is when you can expect to see us live if you're watching live. If you are new here, there's a YouTube link in the Twitch description. We repost all of our projects organized into playlists. So right now we're working on this demystifying the Linux graphics stack. So if you want to like catch up on this, there's all of this, but there is also other stuff. Like we wrote an operating system at some point, and like a QR code scanner, and like a map, and like a WASM-based Rube Goldberg machine and a video editor. So if you want to like check all that stuff out, that is there. There's a GitHub link in the Twitch description. This will eventually end up under the GPU testing environment stuff if you want to see it. If you want to like take a look at the code, there's a Discord link in the Twitch description if you want to talk about stuff while we're offline. If you want to see kind of like the 12:30 to 2 segment in VOD format, those are archived under Patreon and YouTube under the join button. So this is like you're seeing right now kind of like the focused new feature work section of the stream, but there's also this like refactor kind of cleanup vibe, just shoot the shit type section of the stream called Happy Hour. And so if you want to check those out, those are either caught live at 12:30 or in the whatever, the Patreon or YouTube members. All right, I think that's all the plugging. Thank you for watching. I'm excited. And so let's say goodbye to YouTube and Twitch. Let's find someone to raid.